Thank you. So I want to spend a few minutes talking about our vision for a graph platform. Neo4j has a vision for being far more than just a graph database company. We have a vision for being a graph platform company. The idea being that in order for developers, architects, companies to be successful with Neo4j, it takes far more than just the database itself. There is an ecosystem of tools, an ecosystem of partners that surround the database that make it possible for Neo4j to be a truly usable tool within the enterprise and for developers. There are a lot of components around this, and I realized that my time got cut down from 30 minutes to 20 minutes, so this may be kind of quick. So I'm doing my best. Historically, Neo4j has been really, really good for graph transactional workloads. This has been where we've come from, what we've done best. OLTP for graph. Increasingly, we see customers using Neo4j for analytic workloads. Customers realize once they have their real-time transactional data in Neo4j, that they can gain insight from that transactional workload by doing analytics on it in the same database. Historically, you've had to pull that transactional data out of a database and put it into an OLAP system to do analytics. With Neo4j, you can do analytics directly on the database against the real-time transactional data and get real-time feedback in analytics. Gartner calls this HTAP, Hybrid Transactional Analytic Processing. Forrester calls it translytics, when you have all of this in one single system. Whatever the term, we just think it makes a lot of sense that you have one system where you can do all of your transactional and analytic processing. What we've done to enable this is we've released a series of graph algorithms that allow users to do some fundamental graph analytic processing within Neo4j. Some of the key components of that graph algorithm library are the ability to do pathfinding within the graph to find the most efficient route through a path, to do community detection. So to take a graph and then find the important clusters within that graph, and to do centrality. So within a distinct network of nodes, to find the most important node in that cluster. What's really interesting about this graph algorithm library is that this was work that was actually developed by Michael Hunger. And we have released this as an adjunct to the product. It's an initial release, and yet we've seen that the performance of the graph algorithm library stands up amazingly favorably to mature graph algorithm products out there. Comparing ourselves just to GraphX, we're massively faster than GraphX for things like PageRank. So when you think about the opportunity to do analytics in Neo4j and thinking about Neo4j as a hybrid environment for both OLTP and OLAP, and doing that within the same cluster, not only is it a theoretical story, the story really stands up. You can really do this stuff, and it really performs, and it performs far better than the stuff that's already out there dedicated to doing these kind of graph algorithms. Now, once you have the transactional data in Neo4j, you have the analytic data in Neo4j, and the transactional data is flowing in real time, and it's informing the analytic data out the other end in real time. What you have is a feedback loop that is akin to, we have this circle here. We call it AI. I'm not totally sure I'm crazy about that term AI, because it's not artificial intelligence, but it is this feedback loop of intelligence in the data set that's informed in real time from the transactions that are coming in from your real-time systems. And it allows us to do really, really interesting stuff with recommendation engines, with fraud detection, that you can do in a real-time way that in typical machine learning exercises, you'd have to take all of this data offline, put it into another system, generate a model, put it back into the system, and then run all the data against that model to try to determine whether or not you've improved things. With a graph database, every time new data flows in on the transactional side, it immediately updates the analytics side. So in the example of a customer in an e-commerce system, anytime they make a new purchase, that immediately affects the way recommendations are made to customers like them visiting the store at that moment, which is really remarkable. You don't have to take any of this stuff offline, run it through any sort of models, and pull it back into the system. You can affect the recommendation system in real time by the behavior of users as they use the system. It's a pretty transformative way to think about machine learning. Now, the next fundamental underpinning of a graph platform, as we think about it, is data integration. In order to think about Neo4j being a valid and first-class data citizen in the ecosystem, we need to think about how do we get data into and out of Neo4j. Now, we've built a number of tools to make it possible to get data in and out of Neo4j. Those tools include command line tools like Neo4j admin import, or tools within Cypher to help load CSV. We've created newer projects to ETL from relational databases. But this is just a start. There's an opportunity here for us to integrate with the broader ecosystem of data transformation and data ingestion products in the data pipeline. What we see is that there's both a partner opportunity within the Neo4j ecosystem for partners to build into the data integration framework and enable customers to pull data from other systems into Neo4j, and for us to integrate with other data integration products like Talent, which is already integrated with Neo4j, to bring data into Neo4j and to pipe data out of Neo4j into other systems. There are a lot of ways in which we see Neo4j integrated into existing enterprises for data ingestion. The most common way is we see customers ingesting data from tabular systems. Whether that's a relational database or flat files, customers are using load CSV or they're using Neo4j admin import, and they're pulling data from a simple flat file into Neo4j. Some of the more interesting ways, and Emil alluded to this when he was talking about the cancer trials, is when we have a distributed, siloed collection of data sources in the enterprise, and customers want to pull data from those various silos and create a system of record that combines all of them. Now here, data could be in relational databases, document databases, key value stores, and the method of integrating data into Neo4j could be bulk, or it could be real-time. And so customers can be using scripted tools, or they could be writing directly to the drivers that we provide to integrate data into Neo4j. It gets really interesting when customers are doing real-time integration, because then Neo4j is this cross-silo system of record that allows customers to get insight into data systems that they previously had no vision across. And then finally, we we've been working on products to enable customers to materialize graphs out of data lakes so that customers can get real-time insight into the graphs within their data lakes, specifically Hadoop. And we don't have a product to announce there, but we have some work going on there that should be seeing the fruits of in the coming months. The important point about this is there are many ways we've currently provided to get data out of existing systems and into Neo4j that are both at the low level and at the programmatic level and at the tools level, and that support both batch and real-time integration with Neo4j and allow data to flow in both directions. Having discussed how we get data in and out, one of the important ways is programmatically, and it leads us to think about drivers and what do we do on the driver front. And any platform discussion around the Neo4j database, we've got to think about how do we allow for integration with Neo4j. On the drivers front, we've got a pretty strong story. Neo4j has native language drivers for Java, .NET, Python, and JavaScript. These native language drivers are relatively low-level drivers. The goal of these language drivers is to take care of the really messy stuff of dealing with clusters and allow developers, community members, and partners to build the higher-level logic on top of that, of building object graph mappers so that they don't have to think about the lower-level stuff. Expect to see more language drivers from us, particularly over this coming calendar year, so that customers and community members can build higher-level abstractions on top of that. At the same time, although we've released native language drivers just for these 4, the community has done a huge amount of work to release language drivers for a variety of other languages. I've listed just a few here. And then partners also have released language drivers. GraphAware, notably, has released a PHP client that's really robust and supports the Bolt protocol. If you take a look at the developers section of the Neo4j website, you can see language-specific examples of integrating with Neo4j, and you can see how straightforward it is to do with each of these languages. The point of this platform wrapping around Neo4j is that in each of these components, we've done a fair amount of work, but there's a lot of work left to do. And that this is a vision of where we're headed with Neo4j and the platform, and that the work that we've done is a pointer in the direction of what we can do and also what partners can do and where we can integrate better into the ecosystem. The next component of the platform is discovery and visualization. In order for business users to get real value out of Graph, they need an easy-to-use way to understand the data within the graph. And that's not Cypher, not for the business user. It's a way to visualize and navigate the data within the graph. Now, we've done some work ourselves on this, specifically the Neo4j browser. The Neo4j browser is a really developer-focused tool. How many of you here have used the Neo4j browser? OK, that's a lot. Great. It's really useful for basic use cases. It's useful for development. It's useful for query tuning. It's useful for understanding the context of a specific problem set you're working on. If you're trying to do anything that is more business focused, is trying to solve a specific problem of visualization of the graph for a business use case, generally the browser will tend to fall down because it's not a business use case focused product. So the next place people usually move is to JavaScript libraries. JavaScript libraries enable developers to build a custom visualization of Neo4j and tailor it to a specific business problem. There are a number of JavaScript libraries out there that allow for graph visualization. The JavaScript libraries are fantastic, And they're great if you have a very scoped vertical business solution you're trying to solve. If it's a lot about reading data and presenting that visual data for a specific slice of the graph. If you want to do anything very interactive and navigating the graph, you're going to find that you're going to start writing a lot of code, and the JavaScript libraries are going to fall down. When it starts to get cumbersome, it's time to turn to the partners of Neo4j, who have built really rich visualization, discovery, and navigation applications around graphs. Specifically, Linkurious, Tom Sawyer, and Cambridge Intelligence have built some fantastic tools specifically tailored to graph visualization and navigation. Whether it's fraud detection or threat hunting, these guys have amazing tools that solve these problems and more very, very well. So in the discovery and visualization space, we have a really rich story. And we expect that this story is going to expand. Expand into the analytics space and integration with existing tooling for BI. There's a lot of opportunities here in discovery and visualization. The next piece is development and administration. At Neo4j, we've built a number of tools to enable development and administration, and there haven't been, the two that pop to mind are the Neo4j desktop, which we talked about a little bit earlier, and the Neo4j browser. There's also command line tools that allow for administration of the database. What we haven't done to this point is we haven't integrated with some of the more standard tools that you'd expect from a relational database environment. You know, relational has 30 years of history of building up DBA-type administration tools. There's an opportunity there for partner network and for us to integrate with tools that enable for more rich database administration for administrators and for developers on the use of and monitoring of and deployment of Neo4j as a solution in the enterprise ecosystem. Our tools alone give you the ability to manage a Neo4j instance, understand what's going on with the Neo4j instance, interrogate it, work with it. But we can work better with the broader ecosystem of tools for systems administration and database administration. And this is a direction that we need to take. We need to extend further, and will. And then finally, analytics tooling. I've talked a bit about analytics and the importance of analytics and how we see more analytics use cases coming into Neo4j and how natural a fit that is. Has anybody here worked with Cypher for Apache Spark? One, two. Well, yes, you have. Of course you have. Okay, so Cypher for Apache Spark, somewhat like Cypher for Gremlin, which I mentioned earlier. Cypher for Apache Spark is another product of the Open Cypher language group. What Cypher for Apache Spark does is it allows developers, specifically data scientists and analytics-oriented developers, to take data from Neo4j and create a graph in Spark, or take a Spark data and pull it as a graph into Neo4j. On the surface, that doesn't sound like it's earth-shattering, but why it's interesting is because you can create graphs in Spark and then iterate Spark jobs on those graphs. And much like Spark SQL allows you to create tabular data in Spark and then iterate Spark jobs on that tabular data, Cypher for Apache Spark allows you to create graph data in Spark and then do iterative Spark jobs on that data. So the data that you ultimately want to end up with out of a Spark job is often very graphy. You might as well be working on graphy data throughout the process. So Cypher for Apache Spark, and what the example that you see here is two named graphs that are stored in Spark that came out of one graph of attendees to a Graph Connect, and were stored as two separate name graphs, one for North America, one for the EU. And they're two entirely separate graphs that were stored in Spark and can be queried independently. As I said before, the fundamental idea behind Cypher for Apache Spark is that whereas Spark SQL is the language for dealing with relational databases, the relational data in Spark, Cypher for Apache Spark is the language for dealing with graphs in Spark. Okay, so overall, what does this platform mean? Why do we talk about this platform vision? It's, as we've talked about internally, this is one of the first things we've ever talked about publicly, which actually wasn't a product, which actually wasn't something we were done with. It's a vision. Why the heck are we talking about something that isn't done? Because the idea of a platform around Neo4j gives us a framework to talk about how do technology partners plug into Neo4j. What is a well-formed structure for how do we talk to partners about the technology ecosystem around Neo4j, and ultimately how do customers get better technology from partners that can integrate with Neo4j? And how do we articulate the Neo4j roadmap around the tooling that will exist around Neo4j for all of the pieces of the platform that I talked about, so that you can understand both where we see the needs around Neo4j and how Neo4j is going to grow to extend into all of those areas. Now, one of those specific areas is the developer tooling and visualization. We talked about it both in the context of desktop, and we talked about it in the context of the browser. What I'd like to do is I'd like to bring up Michael Hunger to give you a little demonstration of some of the work that we're doing in that environment.
Thank you. Thank you, Kurt. So I give a really quick demo of what's possible today, or what we want to make possible. We want to use the Paradise Papers as example dataset for that. So I'm gonna pretend to be a Swiss investigator who got just my hands onto this really juicy data, and I want to find people in around Zurich that are related to this data. So let's hope the demo gods are helping us today. So we got Neo4j Desktop that you've seen before. Neo4j Desktop is centered all around managing all your graphs, and you manage them in projects. So here on the left side, you see a number of projects. I can create new projects, and within one project, I have a number of graphs that I can manage. So for instance, here in these projects, I have more, but down here, I have a project that contains one graph for GraphTour 2018, which is Paradise Papers. Within these projects, we can manage our graphs, we can look at log files, interact with the terminal, manage the settings, install plugins like the APOC procedure library and the graph algorithms. So if you want to use graph algorithms yourself, you can just grab them, install them. I already did this here in this case. And so you can also upgrade the database. Something else that's really interesting in Neo4j Desktop is on the top, you've seen so far most often just Neo4j browser if you use Neo4j Desktop yourself. But you can, and we're working on the ability to add and install more applications. So in the future, it will be possible to grab applications that have been developed by partners, that have been developed in-house, that have been developed by us or the community, and add them to your Neo4j Desktop. And some of that I want to show you today. So I already started the database. Real quick, if you downloaded the Paradise paper data from the ICIJ ever, then you got something like the There's Paper Explorer, which is a really simple example app that runs on top of Neo4j desktop and makes it easily accessible. So for instance, if I was to look for data in Zurich, I would say I look for addresses, put in Zurich as a name, and look for these, and this runs against my database, and here I get a bunch of these addresses. So I see already there's data that's relevant for me in this database. But it's quite a lot of data, and in this card view, I can't really see a lot. I could also look at the simple application here in a graph view. But actually, I want to use a tool that's more suitable for a business user, similar to what Kurt mentioned. So there's this Acme Viz visualization library that is something that we have here as a demo. And this Acme Viz is actually a tool that uses not Cypher to interact with the graph, but kind of natural language search or structured search. So we kind of use the metadata that we have inside of the graph of the entities that we have there, the relationship types that we have there, to enable people to structurally search across the data. So for instance, I could say, I am looking for officers that have a registered address. So you see that I get type completion, and I can just continue to press my tab key, and with a name, with a name, and then Zurich. Right? So I kind of typed my way through this thing, and I get not just a fixed search, which is kind of templated, but I can go in any direction. So I can go from officer to entity, I can go from officer to law firm, and so on. And if I hit return here, it pulls the data from the graph, and you see that's more than I expected probably. So it's 444 officers or people that interact with shell companies and 280 addresses. And then I can interact with that. I can zoom in, see the companies, see the people. So you might spot some names that you might have seen before. But in general, that's kind of a way of interacting with the data. So that's kind of a lot of data. But what happens, or how could I make sense of this in a way using these analytic capabilities that Kurt mentioned? So if you go to Neo4j desktop again, go to our Neo4j browser that we all know, we can, first of all, look at the database schema, the inferred database schema again. So we have, in this case, officers, so people interacting with shell companies, the shell companies themselves, here called entities. Some additional information, intermediaries are law firms or banks that create shell companies and addresses. So that's kind of our basic data model, right? So, but if you want to find relevant people in Zurich, what I would like to do is to look at what are kind of repeat users. So what are people, or where are people that repeatedly or jointly interacted with shell companies? So in this case, I take 2 officers which interacted with a shell company, and both people have to have an address that's in Zurich. So I have like this quite complex graph path, which would be probably like 12 joins in a relational database that kind of extract this information. And if I look at this, I can run this query against my database and see this is a bunch of joint interactions with the same shell companies by repeated pairs of officers. What I now can do is actually to take this data and materialize relationships between those. So I take my data that's officer, entity, address, intermediary data, and turn it into an officer-officer graph, so person to person, with the number of interactions. So how often did they jointly participate, be in shareholder, director, whatever, of a shell company. And this is by just taking the statement that I just had, and instead of just returning it to me as a user, I just create a relationship between the two. So there's a common investments relationship between the 2 people, and I set the frequency, so how often they interacted, as an additional weight property. So if I do this, it runs the statement, creates 1,100 relationships and puts the properties on these relationships. So if we query our data again, we would see these relationships in a second. But something that I now am able to do on this person-to-person network, so you know perhaps that many of the graph analytics algorithms are running on single entity type networks, so person-to-person networks or document-to-document networks. And that's what we can do now as well. So we can use these graph algorithms which we implemented as Neo4j user-defined procedures, and for instance, just create a random PageRank on our offices. So we just say, give me all the offices which have this kind of common investment relationship, and then give me the common investment relationships, run the PageRank algorithm on top of that. And so it runs in total in 400 milliseconds or something like that, and computes the PageRank in this kind of close-knit community, computes the PageRank, and now with the PageRank we can see who are the most relevant or most influential people in this small joint investment network. And now we can look at this PageRank property. So we just find all the offices that now have a PageRank property and return the top 10 offices by PageRank. So we see there's some people there, but also is some one really interesting company here, right? PricewaterhouseCoopers, you might heard of them. So they're also part of this Paradise Papers data. And now we can take this information, for instance, go back to our Acme Viz visualization and run this statement again. So we find an officer with a name like that. And so if I look for this officer, come on, we get one element here. And we can actually configure what we want to see. So actually, in this case, I also want to see the PageRank property. So I can just select the PageRank property as an additional caption here. And now you see not here, but because it's too long, the name actually. But we can see it for other people. So if I expand this node to its neighbors, so we see for many of the other connected nodes that have this common investment relationship now that we just created, we see actually their PageRank displayed here. And so the visual interaction is one way of interacting with the data, but we can also use this card view over here. So this is our PricewaterhouseCoopers. And now we can, for instance, look at the properties of this node, but we can also follow relationships. So, and here you see that we have the common investment properties relationships. And so we find here one person which has quite high PageRank, so 1.4, Peter Guillier. And we can find this person as well. Let's see, should be actually visible somewhere in my graph. Let's see. Is he highlighted? So is this Peter? Yeah, that's not Peter. I should see him somewhere. Anyway, oh yeah, there he is. So he should be highlighted. So if I actually am an investigator, I also use other sources. So what I could, for instance, do is, where's my other, there you are. So for instance, I would look at online sources, and here I find Peter Guillier at Bloomberg, and I see he's the head of alternate investments at Swiss Re Alternate Investments. So it's kind of an interesting job description, right? I think I would like to have this job as well. And now what we can do is to, for instance, also look at how is Swiss Re related to that. So we can also just find the officer that have a name like Swiss Re. And you see that this graph visualization is actually additive, so it doesn't redraw the whole graph every time like Neo4j browser does, but every statement that I run adds data to this graph, right? So I have now PricewaterhouseCoopers, we have Peter Guillet, but we also have the other Swiss Re nodes that were additionally loaded here to my graph. And if I now expand Peter Guillet's node, I actually see that suddenly connections popping up that connect him to the Swiss Re folks. And one of those is actually over here, a company in the Bermudas, which kind of is really interesting. So this is just a really quick example of how a set of applications that are added to Neo4j desktop can be used by a customer or by user or by developer to get additional information of the graph, to get the initial capabilities exposed as well. And then in the future, you will be able to add more applications there. And we're looking forward to work with a set of launch partners to build these kind of applications to be added to Neo4j desktop, to be released in the near future. And that's for my demo. Thank you. By the way, if you want to know more about this, then feel free to come to the Graph Clinic, ask me later, or ask any one of the Neo4j staff around if you want to know more, learn more about these capabilities, or anything about the graph platform that Kurt talked about. Thank you. So we switch to the next presentation, right?
Thank you, Kurt and Michael. I think it was an impressive demo, right? You've seen all the capabilities of the product, which was, I guess, very interesting. But what we see now is kind of a high-level overview so far from Emil, but then also a deep dive into the product from our product management team. What we will see now is kind of real-world examples. So let me introduce you to our friends from Daimler. And I'm just trying to find Christina. She's currently being set up. So we have Jochen and Christina from Daimler AG talking about their use case where they are leveraging the power of Neo4j in an application. Over to you, Jochen. Thank you. You need the mic? Yes. Why?
Because I don't want to shout that loud. Okay, so we were told we can also do the presentation in German. I think we will do this. And Emil, you can also improve your German listening skills. Also, ich gehe jetzt über ins Deutsche. Ich hoffe, die Christina ist bald verkabelt. Also, Dankeschön, dass wir hier sein dürfen. Das Wahnsinns-Echo hier drauf. Ja, wir sind... Ich warte noch kurz. Ja, wir sind überrascht worden zunächst mal von der schlechten WLAN-Qualität. Also ich hoffe, dass es funktioniert. Der Rechner ist so dreiviertels tot, aber es müsste trotzdem gehen. Also wir sind Christina Lampert und Jochen Linkohr von der Daimler AG. Wir sind in der IT für den Personalbereich tätig. Ich leite dort das Team Data Integration, Analytics und Innovation. Ja, unsere Ziele sind im Wesentlichen Applikationen zu machen, entweder direkt für alle unsere gut 250.000 Mitarbeiter oder Applikationen, die in irgendeiner Weise auf den Personalbereich positiv wirken. Insofern zeigen wir heute mal ein bisschen einen Ausgriff mehr aus, ja, das ist mehr eine Prozesssicht. Also wir hatten es vorhin von Kurt schon gehört, die Business-Präsentation oberhalb von so einer Datenbank ist natürlich auch wichtig, vor allem wenn die Kunden damit arbeiten wollen, also mehr im Business. Ja, zurück, was haben wir gemacht? Also wir haben irgendwann mal so das Problem erkannt bei uns, wir müssen, ja, es funktioniert, ja, wir lassen es einfach schon. Wir haben das Problem erkannt, dass wir, wenn wir verschiedene Reporting-Strukturen haben, also wir haben Reports-Strukturen, wir haben Standortstrukturen, wir haben verschiedenste Strukturen, da geht die Christina nachher noch drauf ein, dass wir da irgendwie ein Tool brauchen, um das zu managen. Und ich weiß nicht, wo ist der Stefan? Ah, da hinten, Stefan. Wir standen vor einem Jahr etwa in Köln beieinander an so einer großen Tafel und haben gesagt, also irgendwie ist es schon wahnsinnig kompliziert, aber mit Neo4j müsste das eigentlich super, super einfach sein, weil das ist ja nur so ein paar Knoten, ein paar Strukturen und dann schaut man es halt mal so rum an, mal so rum an, mal so rum an. Gesagt, getan. Wir haben dann gesagt, ja, das probieren wir mal aus. Ich bin zurückgefahren nach Stuttgart, habe dann die Christina bei mir im Team gefragt, wie wäre es, sollen wir da mal eine Applikation basteln? Ja, und dann, jetzt ist sie live, die erste Applikation bei Daimler, die Neo4j wirklich einsetzt und auch produktiv ist, also insofern gebe ich dir jetzt die Bühne mal frei. Christina, zeig uns, was da entstanden ist.